All right, multiplying a matrix by a scalar. So first off, scalars are just like a number outside. It's nothing fancy. Like in A, the scalar is 3, okay? And in B, the scalar is -2. And you're going to do exactly what you think you're going to do with that number. You're going to multiply every number in that matrix by 3. So for A, I'm just going to do 3 times -2, that's -6. 3 times 0, that's 0. 3 times 4, that's 12. And 3 times -7 is -21. Okay? Makes sense? Because when I look at this, it says 3 times that matrix. And that's all the things in the matrix. So I would just multiply everything by 3. Here, this would just be -2 times everything in there. So it'd be -2. -2 times -2, that's going to be 4. -2 times 0 is 0. -2 times 3 is -6. -2 times -4 is 8. And -2 times 5 is -10. All right, straightforward, right? There's nothing fancy to that. All right. This mumbo jumbo. This stuff is pretty much saying I can do whatever I want to a row. Now, why can I do that? Well, remember when we were doing linear combinations, like the elimination method, I could multiply one equation by like 2 or something like that, right? Remember, these lines in the matrix represent like equations. So I can multiply a row by a single number and not do anything else to it. So this says in A, it simply says multiply the first row by 1/2. So this is typically denoted as 1/2 R1, meaning half of row 1. So I'm going to multiply this row by 1/2. So half of 2 is 1, half of -4 is -2, half of 6 is 3, and half of -2 is -1. And then I keep the rest of the matrix as it was. Now, why might I want to do this? Well, in higher mathematics, okay, specifically in linear algebra, what I would do is instead of doing elimination via like our equations like we did where I multiplied the top row by 2 and the bottom row by 3, and then I got the same number of x's and then added or subtracted them, I can do that with this. So from here, if you think of it as the first column is x, second one is y, third column is z, and these were, say, my answers. Right here, I could subtract the first row and the second row to cancel out my x's. Okay? So what I'm allowed to do here is I'm kind of gearing away from those variables and more so of just the meaning of what the numbers are. But we're not really going to get into that. All right? You just need to know I can multiply a row by 1/2. And in this one, I'm going to multiply row 2 by -5. So I'm going to do -5 R2. That's going to give me, so I'm going to rewrite the first row, 2, -4, 6, and -2. And now I'm going to multiply the second row by -5. So that's going to be -5, -15, 15, and 0. And now I'm going to go ahead and rewrite the bottom row. And as you can see, I might want to do that so I could cancel out that first column there. See how -5 and 5, do you see that, Jay? So I could add those two rows together to get rid of that. All right? That's linear algebra. That's more of like college stuff that you might see. What's up?
So it's like the first row, if they're the same, or like the opposite, you can add them.
I could add them and subtract them and cancel them out.
Only if they're the same number, though.
Yeah, but what I would do first is I would make them the same number by like multiplying it by like 1/2 or -5 to make it the same. It's exactly the same thing as the elimination method. Just I'm not putting the variables there. All right. So what I would do is I would say, hey, here, my new row 2 is going to be row 1 minus row 2. And I would just add or subtract those numbers together. And I would rewrite that as row 2. All right. So there's one thing I want to talk about before we go any further, and it's not in the notes, so I'm just going to kind of zoom in here. I just find it interesting, okay? So I want everybody to do this. I want everybody to grab out their calculator, all right? And I want you to type this in for A, okay? I want this to matrix in for A. 1, 2, 3, 4. Okay? And I want you to do this on your calculator because it's going to be the easiest way to do this. And B, I want you guys to do this. I want you guys to do, I'm just going to write it in a different way. 1, 2, say 3, 4, like that. So I have these two matrices, okay? Right? You okay with that, Jake?
Yeah.
Now, we learned in math, this is true, right? 2 times 3 equals 3 times 2. Right? That is true. Agreed? All right, I want everybody to do this. I want you to do matrix A times matrix B.
How do you do that?
So you type in matrix I.
Yeah.
All right.
Like this?
Yeah, you type it in there, and then you type in matrix B. Okay? And you should get, let's see. You should get that. All right, so this is all I'm asking you to do. All right, so type in the matrices and do A times B. So we're just doing this. So it's a 2 by 2 matrix, and the numbers were 1, 2, 3, 4. And then we went over to B, and that's a 2 by 2 matrix. And that was what? 1, was it 4, 2, 3? And then I just asked you to do this. A times B. And hopefully I remembered my matrix multiplication. And we got that, right? We okay with that? Now I want you to reverse it. I want you to do B times A. You tell me. Go ahead and type it in. So now I want you to do B times A. Don't tell me. that what it is?
Yeah.
All right.
How do you do
So
that?
I'll explain it to you. But what do you notice? They're not the same, right? So with matrices, this is not true. Okay? Matrices, A times B does not equal B times A. And it's because of the way you have to multiply matrices, okay? I'm not getting into it, but I do want to bring that to your attention, that with matrices, order matters. So when you're on the SATs and you're typing this stuff in, you can't just willy-nilly interchange things. It changes things a lot. Now, remember when I told you that everything about matrices is about what two letters? What two things? What did I tell you to remember? What did I show you guys yesterday? What's soda?
L times C.
No, close. What's soda? What was it called? Anybody at home remember the soda?
Oh, the soda L. Yeah.
It's the most important thing with matrices. Rows and columns. So the way I did it in my head was you do row times the column. So 1 times 1, 2 times 2. And then I add it. 1 times 1 is 1, 2 times 2 is 4, 1 plus 4 is 5. Row 1, 2 times the column. 1 times 4 is 4, 2 times 3 is 6, 4 plus 6 is 10. That's how I did it. But order matters, and you need to know that. You can't just willy-nilly change stuff. That's why it's A inverse B, and you can't type in B times A inverse. It won't work. Got it? So order matters. Now, addition probably doesn't make that much of a difference, right? Because you're adding numbers. But if you subtract numbers, that makes a big difference. Now, why we have this stuff in here, there's things about matrices that we want to know. One of them is a determinant. The determinant tells us things about a matrix and will be useful in linear algebra, pre-calculus, and calculus. Okay? Determinants, okay, can be used to help us find the area of a triangle in a coordinate plane. All right? It can also tell me or help me determine how many roots are in a quadratic equation, okay? Like it's all a part of that, okay? So a determinant is simply, okay, a function of it, all right? Now, this is how to do it in 2 by 2 matrices, okay? That's very simple. It's going to be, we multiply across, okay, A times D, and we're going to subtract B times C. We kind of draw an X in there, and we do that. It's very simple. All right, now the calculator does it for you, okay? But please don't ask me to do it for a 3 by 3. That's about a 10-minute process for me. I'm not kidding you. It takes a long time to do it. So what we're going to do is we are going to utilize our calculators to do determinants. Now, Leah, you don't have a calculator, do you? Oh, boy. Do you have one at home? All right. I'm making sure. Because the 3 by 3 determinant is a long time, or it's about a 30-second process with the calculator. All right? So watch as I do this with the calculator. All right? And then I'll show you how to do these 2 by 2 by hand, so at least you can follow along. Okay? So with the calculator, what I want everybody to do is I want everybody to go to the matrix, go over to edit, and it's a 2 by 2, so we're going to type it in. So A is going to be 2, -3, 1, and 4. So I'm going to type in, it's a 2 by 2, 2, -3, 1, and 4. All right? And now what I'm going to do is I am going to go back to the matrix function, and notice there's names, math, and edit. I'm going to go over to math. See how the first one says DET? It's not like a pesticide. Okay, it stands for determinant. So we're going to click enter on that for determinant. And then we're going to call up our matrix A. And I'm going to hit enter. And I get 11. Okay? Now, I told Leah I would show you how to do it, right? Ready, Leah? So for A, we're going to do 2 times 4. That's 8, right? And then we're going to do minus 1 times negative 3. That's negative 3, right? 8 plus 3 is 11. So for a 2 by 2 matrix, it probably takes more time to do it in the calculator. But a 3 by 3, it's drastically skewed the other way. So why don't you guys quickly find B and C, the determinants? Okay. Well, I don't know. I told you. That, which is 4, right? Minus that, which is 4. 4 minus 4 is 0. Yeah. 1 times 5 minus 6. Okay?
So it's easier to do 2 by 2.
2 by 2 is probably easier in your head, but a 3 by 3, don't do it. Okay? It will take me the rest of the period to probably do a 3 by 3. No, it's like there's a pattern and you have to memorize the pattern and then you have to flip signs. Like the first one stays the same, then the second one you're subtracting, then the third one the sign stays the same. And then you have to do it like determinants of like different boxes. It's not fun. 4 by 4 is even worse. Okay? Now, Jake, I wouldn't waste my time on a 5 by 5. That's like a day process. Okay? It's like partitioning all the numbers up to 100. All right, now here we go. This is how to do a determinant using the calculator. These are just the directions. So when you go home, Leah, you can come here and you can follow along. Same with you, Cody. Okay? All right. All right, let's see what this is. Using your graphing calculator, solve system of equations in 2 variables. Both equations are in slope-intercept form. Jenna and her friend Jada are having a contest to see who can save the most money. Jenna already saved $120, and every week she saves an additional $15. Jada has already saved $80, and every week she saves an additional $25. Write a linear system of linear equations that represents the situation. In how many weeks will Jenna and Jada have the same amount of money? Okay? Now, notice here, the first way they did it was they entered both of these into their calculator. They went to y equals, okay, they typed it in, they hit second graph to pull up the table, and they're looking through the table to see where the 2 lines cross. So the blue line is the first one, and the red line is the second one. And the blue line is bigger, 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 and here. They are the same. Okay? So it says for the system, the answer is 4 and 180, which means in 4 weeks, they will both have the same amount of money. That's using a table. All right? So we can do the same thing here. All right? So for this, you are choosing between 2 movie rental services. Company A, which charges $2.99 per movie, plus a $20 monthly fee. Okay? So here, I'm going to write in $2.99x plus $20. Okay? And then for the second one, Company B charges $4.99 per movie with no monthly fee. So it says write a linear or a system of linear equations that represents the situation for just 1 month. How many movies could you rent and get charged the same monthly bill? Now, I know you guys can all go through and you can pull up the table, right, Jay? Okay. Here's my thing. I have taught you at this point. You can do it by solving using graphing, which is the table. Okay. You could do it using substitution. You could use it doing elimination, or you could do it using matrices. Right? There are 4 ways to solve a system of equation. And your job at this point is to determine which one's the easiest. Jay, how would you go about doing this? And there's not a wrong answer. How would you like to do this problem? Me too. I'm actually kind of on the same wavelength as you. Leah, was substitution on the forefront of your brain? No, you can say no. You don't know? That's fine. Cody, how would you like to solve this? Jake?
Yeah, probably.
Good. Now, you would have done this, Jay, right? You would have done 499 x equals 299 x plus 20, right? And you would have gotten what? 2x equals 20. You would have gotten x equals 10, correct? Okay. That's perfectly fine. Okay, me, because I want to think outside the box. Okay, I have y equals 499x. And I have y equals 299x plus 20. Well, for me, what if I wanted to use elimination? Watch. Notice everything's lined up, right? My y's are the same. So I subtract, I get 0 equals 2x minus 20. And then right from there, I get 20 equals 2x. And I get x equals 10. See how it's all the same stuff? You guys okay with that? So it says if you rent on average 8 movies per month, which is a better deal for you? This answer is probably answered easier by the graphing method because you're going to want to pick the line that's below the other one. But to answer this question, it's actually going to be the green line, company A. All right. Moving on.
Wait, I have a question for that one.
Okay. All right. Now, remember how I told you guys there was, to solve a system, we did A inverse B, right? Do you guys remember that? You guys okay with that? Okay. Why was I teaching it to you that way? No other teacher teaches you it that way. I teach it to you that way because I want you guys to learn, all right, matrix multiplication. It's like an introduction to it, okay? So what I do with that is I kind of introduce this concept of, hey, you know, I have like this equation in matrix form. How do I go about solving it? Okay. And today, since we're running out of a little bit of time, I'm probably not going to do or show you all of that intricacies behind it. But I do want to show you this new method that some of you guys might like. So it says Anna burned 15 calories per minute running for X minutes and 10 calories per minute for hiking for Y minutes. So that gives me 15X plus 10Y equals 700. She spent a total of 60 minutes running and hiking and burned 700 calories. Okay. So it says the system of equation shown below can be used to determine how much time Anna spent on each exercise. What is the value of X? And the minutes Anna spent running. All right. So here's what I can do with this. Now it's kind of a little different. Remember before I had you enter in the coefficient matrix and the answer matrix. You guys remember that? Now I can enter it in using augmented matrices since we learned about that. So, Jay, can you give me the augmented matrix? of this?
15, 10, 700, 1, 60.
So if I take this augmented matrix, which is a what? 2 by 3, and type that into my calculator. So let's go ahead and do that. Let's type that augmented matrix in. So it's a 2 by 3. And the numbers were what? 15, 10, 700, right, Jay? 1, 1, and 60. Okay, now from here, okay, let's go back and look. It's telling me to use this RREF. And this RREF stands for row reduction. So what they're going to do is they're going to get ones along a diagonal. And that's all it's going to be. They're going to use, okay, elimination to get it there. So this is what we're going to do to get to that point. We're going to go back into matrices. We're going to go over to math. And now we're going to scroll down to RREF, which is B. We're going to hit enter. Oop. So we're going to go over to RREF, which is B. And we're going to call up A. So what does this mean? Remember how the last one spit out 20 and 40? It spit out that one thing? It's the same thing. Okay? This is saying X is 20 and Y is 40. Easy enough?
How did it take it to 0?
It used the elimination. Remember how we were adding lines together and doing those combinations? I was talking about that. And I told you that when we multiply matrices, we have that A inverse B, okay? Here, it's using the row reduction. It's going to reduce out and eliminate the other entries so that we only have X and Y left.
But it seems like it's doing like that.
That's exactly what it's doing,
But I
Jake.
thought you're not allowed to do that.
It's not doing elimination. It's using that concept in eliminating the other entries.
Oh.
So we're only left with X's and Y's. Because remember I said X is the first column and Y is the second column, right? So having a 1 in that first column means you're only going to have one X. And that one X is going to equal that number because there's no other entries. Okay? So we can use that model to kind of answer these questions. All right? So how would I do it here? Well, it says a fundraising dinner was held on 2 consecutive nights. On the first night, 100 adult tickets were sold. So I kind of have A, and the next one is C for children's. So it says 100 adult tickets, so 100 A plus 175 C, and that's going to equal a total of $937.50. On the second night, it said 200 A plus 316 C, and I made a total of $1,790. So the key here would be to change that to an augmented matrix of 100, 175, 93750, and then this would be 200, 316, and 1790. And then when I use that RREF, I'll get A equals This is like children's tickets, like $250. Who did it?
But it takes you like 10 minutes to do it.
I'm trying to do it in my head. The RREF.
Yeah, that's on.
What'd you got? 5 and 2.5. So there you go. All right.
So like the first two numbers, they don't matter. Like the 1 and 0, they don't matter.
The 1 and 0 are just telling you that if you think about it in this context, ready, Jay? So it's giving you 1 in this column, and then in this column is a 0, right? So it's saying 1A plus 0C equals $5. Does that make sense to you? Do you see how when you take it out of that augmented form and put it back into this form, it makes sense? And then the other one it would be 0A plus 1C equals 250. So being able to interchange it from one form to the other. Good question.